Hello guys, welcome back to our DSA course. Today we will be talking about the two pointers approach and what problems can we solve using two pointers approach. The most popular problem that we can solve with the two pointers approach is the two sum problem, right? And what happens in two sum problem is you will be given an array, example something like this. So this is basically your array, and what you need to do is you need to find the sum of any two elements from this array, and you have to match it with the target. Suppose my target here is 8, and here what you need to do is you need to combine any two elements. Suppose I combine 2 plus 1, which is equal to 3, so this is not matching with 8. Again, if I check with 1 plus 7, here it is giving me 8. Finally, it is able to match with the target 8. And this is what the two sum problem is about. We need to sum any two elements, or we need to club any two elements in such a manner that it satisfies the target 8. Right? So target can be anything. They can give you any target, and you need to write the code in such a manner that it uh, it matches with the target 8, or it satisfies the target 8. Now, what is the problem here? What is the problem? The problem is nothing that, first of all, what we will do is we will be first thinking of the brute approach, right? So we will be thinking of the brute force approach, and in this brute force approach, what happens is we will be able to solve it. We will be able to solve it, and if you compare a brute force approach with the two pointer approach, the same result you will get it at the end of the code. Same result you will get it. But why we are not considering brute force approach, and why we are considering the two pointer approach? Why is that? Because if you look at brute force approach, how we will solve this, we will use kind of like two loops, right? One is the outer loop and the second is the inner loop, because we need to compare, we need to sum two elements just to get the result, which is nothing but the target. That is why we are requiring two for loop. First outer loop and second is the inner loop. So this will go to last element, right? And we will be comparing this with this and then so on, right? For that, we are requiring two loops, and this will give the time complexity of O n square, which is quadratic, right? And this is very much need to be aware of this, because this is consuming much more time. And if you compare with the two pointer approach is not using any two loop or anything like that. It is just going ahead with simply a single loop, right? Single loop. So basically, it will give me the O n time complexity, the big O notation n, right? Because linearly it will go. Now, if you compare the time complexity, it has reduced the n score drastically to n. That is the reason why we are always preferring to go with the two pointer approach. So I hope you understood why we are going with the two pointer approach rather than the brute force approach. Now coming back to our two pointer approach. So how do we implement, or how do we go ahead with the two pointer approach is, suppose I have an array like this. Suppose I have an array and I need to find any two elements which will give me the target 8 in two sum. Basically, we are talking about two sum only here. So any two elements, if I sum it up, it should be giving me the target 8. Now, what in here with the first pointer, I will point to 2, the first element. The second pointer, I will point to 4, which is the, of course, the last element. and then we will try to move around the pointer just to get our target value 8. Now if you look at here, first I will try to sum up 2 and 4. And is it giving me 8? So 6. So 6 is less than 8, right? So that means it is not giving me 8. That means I need to move the pointer to this direction. The left pointer I need to move to the right. And suppose the sum is greater than, or suppose the sum is greater than target, then we need to move the right pointer in the left direction. But here one problem is two sum cannot be applied on unsorted array. Always we have to apply two sum pointer on, always we need to apply the two pointer approach on sorted array, because it will give me problem while solving it, right? So sorted array it needs to apply. And what will be the sorted array here? The sorted array will be in ascending order. We will try to again rearrange this. So 1 will come first, 2 will come second, then 4, then 6 and 7. Clear? And this is exactly what we are trying to achieve with the sorting of array. And sorting, it will in sorting, it can be log and log n, right? We have merge sort, we have quick sort. So basically, n log n is what we will get as the time complexity for this sorting of the array. Now, after sorting it, if we combine with the n, then also it will give n log n, right? Because this is for what? This is for the two pointer approach time complexity, and this is for the sorting. So this is the result what you will get, which is much more better than the n square which you were getting when you were running the brute force approach. Here now what we will do is the left pointer will point here and the right pointer will point here. So left pointer plus the right pointers, it is giving me how much? 8. So this matches, right? This is getting me the desired result, which is nothing but the target value 8. So this satisfy and we will stop it here. But what happens if suppose the value is something like how do we say it? Something like 2 and then 3 and then we have 4, then we have 6 and then we have 11, right? Now let's consider a different array here, which is of this value 2, 3, 4, 6, and 11. So these are my items in the array. So this is basically the array, and now left pointer will point here, and the right pointer it will point here. So left pointer pointing to the first element, and the right pointer pointing to the last element. Here, if you see, this is already sorted. We don't need to run the sort method again on this array. Now checking 2 plus 11, how much is it giving me? It is giving me 13, but the desired target value is 8. 13 greater than 8, that means we have to move the right pointer by 1. So this right pointer, instead of pointing to 11, now right pointer will be pointing to this 6. Got it? Again, now we will check 2 plus 6. Is this equal to 8 or not? So if it is equal to 8, right? So in this case, it will be equal to 8. That means it is satisfying the desired result or the value 8. Then we will stop it here. Then we will return true. So in this case, we don't need to compare much. We just compared in two iteration and it was done, right? So this is giving me O and time complexity. right? So similarly, you can try out for arrays, sorted arrays, and you can put any number of items in this array. So it can be n number of items, right? N number of item can be concatenated with this array, and you can just check out the two sum problem using the two pointer. This is basically all about the logic. We have discussed the logic section of our two pointer approach to solve the two sum. Now let's go to our coding section and try to code this out. So let me go here. So you can, you can utilize this program it's for the Python online compiler uh, to start fast. And what we will do here is we will try to write the code. So let me create a function first in Python. So def, I will try to sum. I will call it to sum, and here I will be accepting the parameter array, and I will be accepting what the target. Now we have array and the target. Now I need to set the left equal to 0, and right pointer is pointing to what? It is pointing to the last element of the array. And why we are subtracting 1? Because it's starting from 0 and it will go till the last element, right? So if I'm starting from 1, then I don't need to put the -1. Now left and right has been set. What we need to do is we need to give a temporary sum, which is of 0, right? And then after temporary sum, what we will do is if it's not sorted, then we will try to sort the array using new array equal to arr dot sort function. So this will basically sort the array, and now let's write the condition. So condition is while our left is less than right. So whenever left pointer is uh, lesser than right, till then we will go on, right, with the iteration using the while loop. So left is less than right, then what we need to check, uh, we need to find the sum, right? We need to first find the sum because we were finding the sum. Sum of what? Sum of ARR left, and we need to sum it up with the ARR right. Then after getting the sum, what we need to do is we need to check if our sum is equal to what? Target. So whenever if my sum of two element is equal to target, then we will just return true. Otherwise, what we will do is else if uh, our sum if our sum is less than target, right? So basically, if our sum is less than target, that means we need to move the left pointer by 1. So I will just move the left pointer by 1. Similarly, else if my sum is greater than target, then I will move the right to my left side. So I will just subtract it by 1, right? And if none of this matches, then what I have to do? I have to return false. So return false, right? So that is basically the code, and here you can just print what you can just call the function toSum, right? So I will call the function toSum, and then uh, I will give some array. So 2, comma 5, comma 1. I will just jumble it up. I will just mix it up, and then 7, comma 8, comma 11, right? And what is the target here? The target here will be 8. So let's check. Let's run this. Okay, if tag sum equal to target. Okay, here we need to put this colon. Okay, print was never closed, so we need to close this bracket. And okay, so yeah, that's it. So we are getting through, right? We are getting through, and suppose if I give something like so any combination should not give me the desired result, the desired value. So suppose if I give some uh, what unrealistic number like 19 target, then it should give me false. Okay, why it is giving 19? So 18 plus 11, 19. Okay, that's the reason why. So suppose 55 if I give. Okay, so if I give some unrealistic number like 55, which cannot be satisfied by any of the summation of any two elements, then it will just simply print me false. So this will give me O of n time complexity, and this is basically our two pointers, right? Two pointer approach, which we can apply to solve the two sum problem. I hope you understood this, and let's see in the next lecture.